So now let's solve question number 13. Two loudspeakers M and N are located 20 meters apart and emit sound at frequency 118 Hz and 121 Hz respectively. A car initially at a point P 1800 meters away from the midpoint Q of the line Mn and moves towards Q constantly at 60 km per hour along the perpendicular bisector of Mn. It crosses Q and eventually reaches a point R 1800 meters away from Q. Let's T represent the beat frequency measured by a person sitting in a car at time t. Let P, Q and R be the beat frequencies measured at locations P, Q and R respectively. The speed of sound in air is 330 meters per second. Which of the following statements are true regarding the sound heard by the person? So let us consider the situations. So these are 2 points M and N, two loudspeakers that are placed over here. Now perpendicular to this is the path along which the vehicle is moving. So let us consider this is point P with initially with some velocity, the constant velocity is 60 km per hour. So this would be the point Q and this would be the point R, which is again 18. This distance is 1800 meters and same is this distance. So now T is the beat frequency by person sitting observed by a person sitting in the car at time t. Okay, so calculating the apparent frequency of M and N at P. Apparent frequency of M and N at P would be mu M dash. Let this apparent frequency be mu M dash. This will be equals to V plus V naught cos theta. I'll tell you what is V naught cos theta here. So V naught cos theta into mu M, and mu M is the beat frequency for M. So V naught, why V naught cos theta? This is V naught, so this angle would be theta, because the velocity that we'll be considering would be velocity of approach. So at any point this would be theta, so this would be V naught cos theta. So this becomes Vm dash, apparent frequency of M and N at P. So Vm dash becomes this. So putting some values, this becomes 330 plus, we'll keep the V naught cos theta value later, or we'll see if we really need this value. So this becomes 118 Vm dash, and similarly for apparent frequency at N would be 330 plus V naught cos theta upon 330 into 121. So apparent frequencies of M and N at P would be, for M it would be this, and for N it would be this. Now beat frequency. So beat frequency at P point would be mu p equals to nu n dash minus nu m dash. So this becomes nu p becomes 330 plus v naught cos theta upon 330, since this is common, 121 minus 118. So this becomes nu p equals to 3 times 330 plus v naught cos theta upon 330. Now similarly for Q point. So before Q, we like to see for R point. So similarly for R point, since this is the velocity of approach, but here this would be moving away from these two loudspeakers. So nu R becomes 330 minus, in case of plus we'll get minus sign over here, and rest would be same, 330 into 121 minus 118. So this would again be 3 times of 330 plus v naught, sorry, this would be minus sign over here, 330 minus v naught cos theta upon 330. So as asked in the question, Vp plus Vr, this becomes, solving this we'll get when we'll solve this will become 330 upon 330 plus v naught cos theta, plus this would become 330 minus v naught cos theta, and 3 would be the common term over here, so this would be cancelled out. So this would become 2 into 3. Now VQ, sorry, this is not VQ, this would be nu Q. So beat frequency at Q would simply be 121 minus 118, which is equals to 3. So as we see, this is nu P plus nu R equals to 2 into 3 and nu Q equals to 3. So we can say that nu P plus nu R equals to twice of nu Q. So this is what our option D says. So option D is a correct option. Now in order to get the variation of nu with respect to time, we'll see about the condition, how it can be calculated. So let's take another board over here. So considering the same situations, point M and N where loudspeaker are placed. So here is our, let us consider at some distance x our vehicle is approaching, and this makes some angle theta. So at any instant tan theta would be 10 upon x. We know this distance as 10, that is the midpoint, this is point Q. So now we know that nu at any point would be 330 plus v cos theta. Since v velocity would be here, so this would be v cos theta upon 330 into 3. So this would be the beat frequency simply at any point. So d nu by dt, becomes minus v sin theta upon 110 into d theta by dt. So now we already knew tan theta equals to 10 by x. So differentiating both sides, this becomes x squared d theta by dt equals to minus 10 upon x square dx by dt. So we get d theta over dt equals to minus 10v upon x square sec square theta. Now putting this value of d theta over dt here, we see that d nu over dt is proportional to sine cube theta, solving over that equation. So at q, we can see at q theta would be 90 degree. So at q theta would be 90 degree. So definitely d nu by dt will be maximum. So this is our option, which says the rate of change in beat frequency is maximum when the car passes through Q. So C is the correct option. Okay. Now again, we know that at Q the rate of change is maximum. So now since we have two options for the plots, we can directly tell the answer from these two options. Now in diagram A, the slope is maximum at point Q. The slope would be d nu by dt. Since d nu by dt is maximum at Q, so definitely A would be the correct answer. So by this we can see that d nu by dt at P is almost 0, then it is increasing, coming to the maximum value, and then it is again decreasing. So A is the correct plot. So therefore for question number 13 we have A, C and D as correct options. So friends, now let us solve question number 14. Consider two solid spheres P and Q, each of density 8 gram per centimeter cube and diameters 1 centimeter and 0.5 centimeter respectively. Sphere P is dropped into a liquid of density 0.8 gram per centimeter cube and viscosity neta equals to 3 pascals. Sphere Q is dropped into a liquid of density 1.6 gram per centimeter cube and viscosity neta equals to 2 pascals. The ratio of terminal velocities of P and Q. So here we will simply use this concept of terminal velocity. When a sphere is dropped into some liquid, we know that this would be the weight, this would be the buoyant force acting, and this would be the drag force that is given by 6 pi neta rv. So at terminal velocity we know 6 pi neta RV plus rho L Vg equals to rho naught Vg. So we get V equals to rho naught Vg minus rho L Vg upon 6 pi neta R. So simply this is the formula for terminal velocity. So we can simply solve this by putting Vp upon Vq. We have different values we have been provided. So this would be rho p Vp minus rho L Vp into G upon 6 pi neta P R P into 6 pi neta Q R Q upon rho Q Vq minus rho L Vq. So this question is a very simple question. Simply values are needed to be put on the formula and we get Vp upon Vq, that is equals to 3. So 3 is the correct answer for this question. So now let's solve question number 15. Two inductors L1, inductance 1 mH, internal resistance 3 ohm, and L2, inductance 2 mH, internal resistance 4 ohm, and a resistor R, resistance 12 ohm, are all connected in parallel across a battery of 5 volt. The circuit is switched on at time t equals to 0, the ratio of maximum to minimum current. So let's see what this question is saying. So this is our 1 mH and this is our 3 ohm. Now this is again our second inductor with internal resistance 4 ohm, and this is our resistance. So the question is again very simple. Generally integer type questions are quite easy with respect to the questions. So at time t equals to 0, so there would be no current through inductors and our circuit would be like this. So I naught, this would be the minimum current, I at 0, this would be the minimum current, V upon R, simple. So this would be minimum. Now at time t equals to infinity, after infinite time, our circuit would become somewhat like this. This is the resistance, this would be our internal resistance. So after infinite time, this would be our circuit, and we can simply calculate the net resistance over here by using this formula for parallel resistance, 0.12. So R net is equals to 12 upon 8. So I max, maximum current, would be potential V, that would be same upon R. So that would be 12 upon 8. So I max upon I min would become 5 into 8 upon 12 into 5 upon 12. So the answer is 8. So friends, now let us solve question number 16. The isotope 12B5 having a mass 12.014 unit undergoes beta decay to carbon 12C6. 12C6 has an excited state of the nucleus 12C6 star at 4.041 mega electron volt above its ground state. If 12B5 decays to 12C star 6, the maximum kinetic energy of the beta particle in units of mega electron volt. So as the question says, 12B5 is decaying into 12C star 6 and undergoing beta decay. So maximum kinetic energy of beta particle would be Q equals to mass of this 12B5 minus mass of 12C star 6 into C square. This is the simple formula that we'll be using. Equals to change into mass into C square. So now this becomes B5 minus, so now this 12C star 6, mass of 12C star 6 becomes mass of 12C6 plus delta M, which has been provided, into C square. So this will become minus M6 12C6 C square minus delta M C square. So putting the values, we get 0.014 into 931 minus 4.041. This comes to an answer that is 9. So friends, now let's come to question number 17. A hydrogen atom in its ground state is irradiated by light of wavelength 970 angstrom, taking Hc upon E equals to 1.237 into 10 to power minus 6 electron volt meters, and the ground state energy of hydrogen atom as minus 13.6 electron volt. The number of lines present in emission spectrum is. So simply using the equation for change in orbital energy, we have 13.6 into 1 upon 1 square minus, that is 1 for the ground state, upon n square equals to 1.237 into 10 to power minus 6 upon 970 into 10 to power minus 10. So bringing all these values into standard form, so this becomes 12370 upon 970. So from here we can calculate n square equals to 16. So n, the value of n comes as 4. Now we know the number of line would be nc2, that would be 4c2, so that is 6. So 6 is our answer. So now friends, let's discuss question number 18. A metal is heated in a furnace where a sensor is kept above the metal surface to read the power radiated P by the metal. The sensor has a scale that displays log 2 P upon P naught, where P naught is constant. When the metal surface is at a temperature of 487 degrees Celsius, the sensor shows a value 1. Assume that the emissivity of the metallic surface remains constant. What is the value displayed by the sensor when the temperature of metal surface is raised to 276 degrees Celsius? So, as according to the question, when the value is 1, so this becomes log 2. P1 would be the value at that instant upon P naught. P naught is the constant that they are using in this scale, so this equals to 1. So P1 upon P naught becomes 2. Now according to Stephen-Boltzmann's law, we know that P is directly proportional to T to power 4. So P2 upon P1 would be equals to T2 upon T1 to the power 4. So putting the different temperatures, 2767 degrees Celsius and 487 degrees Celsius, and friends, do remember to convert them into Kelvin. So 2767 plus 273 Kelvin upon 487 plus 273 to the power 4, this becomes 4 to the power 4. So P2 upon P1 becomes 4 to the power 4. So putting the value of P1, we get P1 equals to 2 P naught equals to 4 to the power 4. So P2 upon P naught, P2 upon P naught, we get 2 into 4 to the power 4. Taking log both sides, since our reading is in log, P2 upon P naught, we'll be solving this equation. So this becomes log 2 into 4 to the power 4. So this becomes 9. So 9 is our correct answer.